Have you ever looked back at the COVID-19 lockdowns in 2020 and thought, man, that was a crazy year? Within just a few months, it felt like the whole world got flipped upside down because of COVID-19. Well, as crazy as it was for us, at home, rewatching The Office and learning to bake sourdough, it was even more hectic for vaccine labs all around the world as they raced to make a vaccine against the clock. Although vaccine development usually takes 10 to 15 years, we managed to get the Pfizer and the Moderna vaccine in less than a year. But why is that such an achievement? What actually goes into making a vaccine? And how can we be sure that if another pandemic threatens the world, that we'll be ready with an effective vaccine even faster? Hi, my name's Eva, and in Season 2 of Day Zero to Breakthrough, you'll come along with me as we take a look inside an Australian lab trying to prove that they can make a vaccine in less than 100 days. And don't worry, you don't have to have watched Season 1 to be able to follow this one. Right now, I'm standing in front of the Australian Institute for Bioengineering and Nanotechnology, where, in 2022, they developed a new kind of vaccine technology called Clamp2. Clamp2 is a versatile base that can be quickly adapted to accommodate all different kinds of viruses and generate a vaccine quickly. If you're interested in how it works, you can see more information about that here from last season. Over the next 100 days, the AIBN, in collaboration with the Coalition of Epidemic Preparedness Innovations, will be holding a pressure test to prove that they can create a vaccine that's safe and effective in just 100 days. This time, they're trying to make a vaccine for canine coronavirus.
Yes, so here in Keith's Chapel Group for the pressure test, we have this moonshot aim of developing a vaccine from sequence to, in theory, emergency use in the shortest amount possible. We learn from our previous experience, and we are trying to improve in multiple ways to be faster and better.
Last season, they tried to make a vaccine for Shapare Mammarino virus, but they didn't quite succeed. This time, they've learned from their mistakes and what went wrong, and they're confident in their abilities.
So from the first pressure test, we learned that instead of relying on only one supplier, raise different suppliers to see which ones can actually deliver fastest. And we are much more careful now about the timeline, and we feel all much more prepared, and we know what we have to deliver by which date. This particular protein, it's larger, so we'll have unique, not challenges, but differences when it comes to the length of processes like cloning, and in general, it's a bit more difficult to handle, but we are ready for it.
On day one, when I sat in on their first meeting, in just a few hours, the team had already figured out exactly what needed to be done. Even though the genes and even some receptors for canine coronavirus have already been described, that doesn't mean the team doesn't have any work cut out for them. They still have to decide which parts of which genes to target for the vaccine. That means analyzing the virus's genes and designing PCR primers. These are small chunks of DNA that are used to bracket either end of a target DNA sequence, so that it can be copied or amplified into much larger quantities that can be used to make the vaccine. If you want to know more about this process, then catch us next week when we do an episode on PCR. Once these primers are designed, they'll order these exact DNA sequences. Once these arrive next week, the team will start cloning the DNA, and that's where we'll get to see the real science in action. If you want to see what happens next, subscribe to the channel and catch the rest of Season 2 on our journey to make a vaccine in less than 100 days.